Hey everyone, it's your main math teacher, Mr. Boyd, and I'm back at it again today. Today we're talking about how to take derivatives of trigonometric functions. Let's get after it. The easiest way for me to kind of make an understanding of this is if we start out with graphing. And that relates back to our lesson on graphing derivatives. So we're kind of connecting and reviewing as we go here. And so what I've put on here, I've put a sine graph. Just graphed it in decimals, here it is. And the first thing we want to do is try to sketch a derivative. I would suggest you pause the video. I know we're only like 20 seconds in, but I suggest you pause it and try to actually sketch a derivative of this. Okay, here goes. Find your critical points. And then we're going to do intervals of increase and decrease. Okay, they only asked us to sketch from 0 to 8. So my derivative is going to stop at those endpoints. And let's do this. I was increasing here. So increasing. Looks like I'm decreasing. There's an inflection point somewhere in there. So decreasing. Looks like I'm increasing on this interval with an inflection point here. And I back down. Cool. So here I am. There's my curve. So I've got a curve that starts up here, comes down and goes back up. Now again, you may need to pause the video again to think about this question, because what is the equation of that derivative graph? Remember, what we're trying to do is figure out what is the derivative of sine. So take a look. That's a cosine graph. So what that tells us is the derivative of sine is cosine. We're going to do the same thing again, but this time we're going to look at the cosine graph. So pause the video, try to sketch your derivative on this one. Here goes. Critical points. And then where our graph is ending there, they said over the interval 0 to 8. Okay, it looks like we're decreasing. So inflection point here. So decreasing, increasing over this interval, so I'm going positive. Then inflection point is that highest point right there. And then it looks like we're coming back down and decreasing. All right. So my graph is a little sketchy, but we have to figure out what's the equation of that. Well, it looks an awful lot like a sine graph, except a sine graph normally starts here and goes up and down. So this is just a flipped version. So what's that function? It's negative sine. So derivative with respect to x of cosine x is negative sine of x. That's our intro. Today we're going to learn how to use them. There is one little thing that we didn't talk about. Okay, so yeah, derivative of sine is cosine, but very similar to the rules with logarithms and exponential functions. You have to write the derivative of the guts out in front. So for the example we saw, sine turns into cosine. Notice the guts stay the same. Hey, that's just like the E rule. Okay, and so we're going to turn the sine into cosine. It says to write the derivative of the guts out in front. Derivative of x is 1. That's why before we didn't have to write it. So it is technically 1 cosine. That little 1 doesn't do anything, so we're going to leave that alone. Let's get a little bit of fluency with how it's used. Now let's take a look at our first example. Okay, these are two parts of the same question. We're asked for a derivative of sine, so let's go through our progression of our rules. We know that sine turns into cosine. Do the guts stay the same or change? Or do they stay the same? Okay, so there's a negative 2x. We're going to use parentheses so we don't think it's subtraction. It's cosine of that. And then out in front we have to write the derivative of whatever's on the inside of the function. The derivative of negative 2x is negative 2. So there's my derivative. If this was my f function, what we have found, because that said take a derivative, we found f prime. Now we're asked for f prime of pi over 2. So let's just plug it in and see what we get. So we get negative 2 cosine of negative 2 times x, that'd be pi over 2. Alright, 2's cancel. So I have negative 2 times the cosine of negative pi. Alright, think about where negative pi is. Okay, unit circle. 0's over there. Negative pi means we're going the wrong way, and so negative pi would be over there. Cosine's an x value, so that's negative 1. Negative 2 times negative 1 is 2. They gave us an x value. We gave them a y value, as requested. Okay? Let's do another one. Okay, you may want to try this one on your own. Okay, and once you get it, they're not too hard, so check your answer now. Okay, sine turns into cosine, the guts remain the same, and out in front we write the derivative of those guts. So remember, little slide and subtract. So that's a negative 24x squared. Derivative of 5 goes away. There is your derivative function. All right, let's try this one. I would encourage you, before you start any exercise with the derivative, you pause and ask yourself what rules you're going to need. Certainly need the rule for differentiating exponentials. Certainly need a rule for dealing with sine. But there's another one. Do you see it? We need the product rule. We have a function, call it our f function, times another function, a g function. So we need to make a little cloud, make a little product rule. Let's do this. So for f, I'm going to use e of x. Remember how to derivatize that? Excuse me, differentiate that. That would be its own derivative. Okay? G being sine of negative 7x. Its derivative, sine turns to cosine, guts remain the same. Derivative of the guts goes in front. And now let's set up our product rule. Great, we can review. If you haven't seen the product rule yet, I would encourage you maybe to pause here for a second, go back, check out the product rule video before you do this, because what we're about to do may not make sense otherwise. I want to write down my derivative, and so I'm going to call my derivative dy dx, and it's going to go like this. F prime g, so e to the x, times sine of negative 7x, plus, product rule has a plus in it, e to the x, although I'm going to put my negative 7 first. I like my coefficients to go first. So negative 7 e to the x. Remember, I'm multiplying this and that, and then I also need cosine of negative 7x. And the only thing I see here that needs to be cleaned up a little bit is it's not really proper syntax to have a plus and a minus right next to each other, so that actually would just be a minus. Right? But there's our derivative. Okay? So it's not a lot harder. The trick is not in the steps. The trick is in the recognition that that's a product rule. So look really, really carefully before you start going, because sometimes people get all excited. They go, oh, I know how to derivatize that. I know how to take a derivative of that. I'm just going to do derivatives. Well, hold up. You got to make sure you have the right rules. If you don't have the right rules, you're not going to get the correct derivative. So be careful. All right. We've already talked about cosine a little bit. Let's formalize it. We already said that the derivative of cosine is negative sine. However, that same type of rule applies where we have to write the derivative of the guts on the inside. Notice, whatever the guts is, the guts will still be. It just turns into negative sine. So let's take a look at some of those. Okay, you may want to pause and try these on your own. Very similar examples to with sine. Okay, for this, cosine turns into negative sine. We still have the 4x. We write the derivative of that out in front. Plugging in a pi over 3, negative 4 sine of 4 times our input, pi over 3. You may need to draw a unit circle so you can see where that is. 4 pi over 3 is right down here. Sine is asking for a y value, and so that is negative root 3 over 2. So what I have is negative 4 times that sine value, that y value, negative root 3 over 2. Negative and a negative make a positive. 4 divided by 2 is 2. So 2 root 3 is our output, or our y. Let's keep going. Let's get to something a little more difficult. Let's try this one, and then maybe we'll try if we can find a product rule, a quotient rule, something like that, that will challenge us a little bit more. Okay, with this one, you've got your cosine. Remember, cosine is going to turn into negative sine. The guts stay the same. And then we need to multiply by the guts. So I'm going to write just in a little bit of space here, derivative of this stuff, negative 20x plus 3. Okay, now, there's an error, or there's an issue with the way I've written this. See if you can find it. Okay, the issue is right here with this minus. This now says negative 20x plus 3 minus sine. But we know that u prime, it's supposed to be multiplied. So if you want to drag that negative out to the front, or if you want to distribute the negative, that would be fine. Or if you want to put parentheses like this, that would work. My favorite is probably to distribute that negative in this way. So I could get 20x minus 3 times sine of negative 10x squared plus 3x. Okay? But there's multiple different ways to write that are all correct. Okay, let's try this one. So again, we're going to pause. We're going to ask ourselves what rules are necessary to deal with this. Try to figure that out for a sec. Certainly we need a power rule. Certainly we need to differentiate cosine, but notice there's a fraction. That indicates to us that this is a quotient rule. So let's build a little cloud. taking a derivative of cosine, remember that's negative sine 2x. And notice how I left a little space right here? Because we need u prime in there. So I've left space to write that down, and I won't get confused with subtraction like on the last example we did. Okay, and we need the derivative of the guts, that's a 2. All right, we've got our f and our f prime. Let's go with g. G is 5x to the 4th. Take a derivative, 20x cubed. Now let's do our quotient rule. Now you may need to flip back in your notes. You may need to go back to the quotient rule video to remember what the quotient rule actually is. Okay, I'm going to talk it out as I go through it so you can see it, but if that's hard to track with, go back and watch that video or flip back in your notes and find the actual rule. Okay, so I'm going to write out my derivative. dy dx is, we're going to start filling it in, f prime g, and I'm going to combine like terms as I go here. So I have a negative 2 times 5, so negative 10, and I'm going to bring the x to the 4th down, and I'm going to write my sign, so I've captured all the symbols there. So sine of 2x minus, quotient rule has minus in it, g prime f, so 20x cubed times cosine of 2x. Don't forget the divided by g squared. Okay, so g squared, if you want to actually square it, go for it. Knock yourself out. But I'm not asking you to do that. I just need you to demonstrate that this is how you know how to set it up, and make sure you put the little squared on there. And folks, if you wanted to leave it like that for now, that would demonstrate to me as your teacher that you know how to set up a cloud, you know how to identify f and g, you know how to take derivatives of each of those, you recognize quotient rules, and you know how to set up quotient rules. To me, sounds like you know how to do calculus, so I'm going to feel really good about that. Okay, so I'm all good with what you see on the board. Okay, and that is the same one, and we need to now talk about the tangent function. Okay, the derivative of the tangent function. Okay, and so we've looked at sine and we've looked at cosine. By just inspecting the graphs of sine and cosine, it's pretty reasonable to come up with the derivatives. With tangent, it's a bit more challenging than that. And so rather than using a graphic approach, I want to use an analytic approach. I want to actually manually write out what the derivative of that is. But the problem is, we don't know what the derivative is. So how can we figure that out? Well, let's start by thinking about what we know tangent to be. Because tangent isn't just tangent. We can actually break that down into different things, like sine over cosine. Remember, tangent is just sine over cosine. And so if we know that, now we can look and say, hey, I know how to take a derivative of sine, I know how to take a derivative of cosine, and I know those are a quotient, so tangent actually requires the quotient rule to figure out the derivative. So let's do that. Our f function is going to be sine x. We remember that the derivative of that is cosine x. G is cosine x. We remember that the derivative of that is negative sine of x. And now it is quotient rule time. Okay, let's plug it in. F prime g. Okay, cosine times cosine is cosine squared minus g prime f. That's negative sine squared. And notice, I've got two minuses next to each other. Minus a negative is really a plus. Divided by g squared. So g squared is cosine squared x. Now, we make you take pre-calculus before calculus for a reason. And one of the reasons is so you can recognize that numerator and realize that's way too many symbols for what that is. We know from our Pythagorean identities that cosine squared plus sine squared is 1. So what this now says is 1 over cosine squared. And like I said a minute ago, there's a reason we make you do pre-calculus first. It's so you can recognize what that is. Because there's a way to write that with fewer symbols. 1 over cosine is actually secant. So that's secant squared x. So what does this mean? This means the derivative of tangent is secant squared. And notice I left a little space here. Can you predict what belongs there? Just like sine, just like with cosine, we need to write out u prime right there. Now, as far as how to use it, it works the exact same way as sine and cosine do. It's just that instead of writing tangent, we're going to write secant squared. Okay, it's the exact same thing. Okay, so we can do one example, and then we'll look at cosecant, cotangent, and secant. Okay, so we just learned tangent turns into secant squared. The guts remain the same, and we write the derivative of the guts out in front. So that's all we need to take a derivative of tangent. That's done. Not bad, huh? Okay, as far as secant, cosecant, and cotangent, if you want to derive these, if you want to go through the exercise, I recommend it. It's actually kind of fun. You can remember that secant is 1 over cosine. And so you could use a quotient rule on that and you could actually derive it. You can do the same thing with cosecant, you can do the same thing with cotangent, use the quotient rule and derive the rules, and then I invite you to check yourself. Here's what you should get when you do each of those. I would encourage you to take a minute. If you're taking notes along with the video, you may want to pause the video and copy these down into your notes so you have them. We've already explained sine, cosine, and tangent today. The way to use these is the exact same way that you would use sine, cosine, and tangent. So if you're taking a derivative of secant, you're going to write the derivative of the guts, and then you're going to write secant and the exact same guts, and then you're going to multiply that by tangent with the exact same guts. They all work the same way. Okay? That's our video for today. Hope you enjoyed and hope you have fun practicing. See you next time.